Hello everyone, how are you all? I hope all good. So in this video, we are going to solve a lead code problem, minimum time to complete trips. So here is the problem statement. You are given an array time where time I denotes the time taken by ith was to complete one trip. Right? We are given an array in which there are multiple bus and each bus has given the time to complete the trip. Each bus make multiple trips successively. That is, next trip can start immediately after completion of current trip. Right? Means there are multiple bus are available here, and each one can do the trips simultaneously. Means immediately one after, and all the bus can independently work, right? And if the one bus has completed the trip, then the same bus also can start that trip again, right? And each bus also operate independently. That the trip of one bus do not influence the trip of any other bus, right? So you are given an integer total trips which denotes the number of trip all buses should make in total. Return the minimum time to required all bus to complete at least total trips, right? We need to return the minimum time to complete the total trips. The total all the bus should complete this criteria, right? At least total trips should be completed. Maybe greater, it can be greater, but should not be less, right? So here is the example time. This is time array, and each bus can complete the trip in this time. It means, let's suppose take an example. So suppose this is our array. The element is 1, 2, and 3, right? So here are 0 index, 1 index, and 2 index. So the 0th bus can complete the trip in one time, and first bus means 1 index bus complete the trip in 2 unit time, and the second index bus can complete the trip in 3 unit time. Right? Are you getting my point? So let's suppose this is the trip, and the 0th bus can complete the trip in 1 unit time, and one number bus can complete the trip in 2 unit time, and the second bus can complete the trip in 3 unit time, right? So we need to return the minimum time to complete the total trips, right? This is our total trips, that is 5. So we need to complete the 5 trips. So if the time is 1, then we can only complete this trip, right? At the time of, if time is 1, then we can complete this trip because this bus has time to complete the 1 unit. But this first and second bus cannot complete, right? Because the time for completion is greater than the available time, so it cannot complete. So now we we increase the time by 2, right? If we increase the time 2, then this can complete 2 time. Means, as we have mentioned in the question, that the one bus can start immediately after completion of the one trip. So this bus can complete the 2 time. This bus can complete 2 time trip, and in this bus can complete the trip in 1 time, and the number of bus to second bus can not complete any trip because the time for completion is greater than the available time, right? So here we have total number of current trip is 3. We need 5. So this time also does not contain the availability, so we increase the time by 3. Let's suppose we have 3 time, and we want the total minimum total trips this. So in this time we can if the 0th bus we take, then we can complete 3 trips. And if we take one bus, first position bus, then we can complete one trip because the two, if in this time we can first time 2, then available time is 1, and in one time we cannot complete the 2 availability of time. So we can only complete the only one trip, and in 3 we also can complete one trip. So here we have 3, 1 and 1, which is 5, right? So at least we need 5 trips, so the total trips is done 5. So we will return this minimum time. This is the minimum time to complete the trip, right? But in this problem there is one problem, that we are searching here linearly, means 1 2 3 and 4 and so on, right? One, we have searched, two search, 3 and 4, 5. So we don't know how many number we require to complete this task, right? So what we can do, we can simply use binary search, because in this algorithm we the our program will take lots of time, and time complexity will go lots, and maybe it might throw an error of runtime. It might throw in time complexity error, right? So for reducing this, we are going to solve by using binary search, right? So we have given the start time is 1 and the end time is 10 to the power 7, right? End time is 10 to the power 7, and we are using here this value, we are using long. So we will use the long value, that is 10 to the power 14, right? Long the int max long max value is 10 to the power 14, right? So here we have 14. So first we will check in the middle. If the middle value is fulfilling the condition, if the middle value is fulfilling the condition, then we will fulfilling the condition and return the minimum time, then we will return this mid value element. But if it is not returning, it means the total trips here are less. Total trips are here less, then we will move ahead. And if the total trips are greater, then we will check here, because we need minimum time to complete this, right? So I guess problem is understood by you. So now we code it. So we will use the binary search here, right? So we need a variable long, which is first is start variable 1, and long end variable, that is 1e14, right? This shows the long maximum value. Long variable can store this much value, right? Now we will use a loop start end. This is for a binary search. And now we will check this mid element. In this time, let's suppose this, in this type, how many trips we can count. So in this time, there here it can complete 3 trips, it can complete 2 trips, it can complete 1 trips. So the total number of 5. So we will check each number has total number of trips, right? So now we check, we will use here one more variable, count trips. Initially is 0, right? And now we are going to use a loop which is start from 0 and end from end till time dot size. This is loop, right? Because we are going to check in the array for each buses that this bus can complete the task, this bus can take trips this much for this time of period, right? So we are going to use I is 0, and now count trips plus mid divide time I, right? Mid divide time I, because this is the mid element, and mid element we will check, this is mid element, we will check this first bus. This time we use this 3 right here. And now the second time, this is time, and this is mid element, so mid will divide by this time, so we can take this only one trip. And for this we can take only this one trip. So we will divide by this, right? And increase I by 1, because 1 by 1 the bus is changed. Okay, so we need to calculate the mid element here also. Mid element, long mid start plus start minus and divide by 2. This is for taking the mid element, right? So now we can total number of count we can find. If the count trips is less than total trips, it means we need to move ahead. We The mid element is not fulfilling the condition, so we will change the position of start is mid plus 1, otherwise end will become mid minus 1, right? This is the binary search you all know, right? And then return start variable. Now we run it and we check. Okay, there is an error, so we check the condition is overflow here. Now okay, we made the silly mistake here, the start and we need to just interchange, because start end is capital and start is less, so that should be interchange, right? And now this all the thing is correct, and now we can submit the solution. We can first run the solution, and if all the test cases are correct, okay, this is correct, and now we can submit the solution. So let's submit. Okay, this solution is correct, right? This is accepted. So thank you very much for watching these videos. Till then, keep learning and keep exploring, and do more and more questions as much as you can. Without that, you cannot achieve your targets. So do more and more questions. Thank you very much.